Hey everybody, I wanted to spend a little bit of time discussing extraction and what extraction looks like, and I'm going to use Lab 9 as kind of the basis for extraction and what extraction should look like for you, but this is a general video on how extraction should be performed regardless of the lab that we're doing. So let's take a look. Okay, before we get started on looking at extraction, we should probably figure out what extraction is and like when to use it. Extraction is used to separate two miscible liquids. In grade school, you've learned that oil and water don't mix. So here's some water, and then here's oil, okay? And they're going to form two layers. So what we know is, since they form two layers, we could actually take and pour the organic layer or the oil off of here and leave the water behind in the flask, in the round bottom flask. Well, that's all great, and we can do that. That's called decanting. But we might as well use this. We have this specialized piece of equipment called a separatory funnel. Okay, and the separatory funnel is going to do the same job. Okay, we dump the liquid in here, and then you can really see very well the different layers that are forming. Now, the shape of this is going to help us separate the layers. What we're going to do is drain the water out the bottom, and because this is tapered, we'll really get a sense of where that interface is between the water and the oil, so that we can actually see to get all the water out of it, or almost all the water out of it, and leave behind all the oil. Okay, so now the only modification that you need to think about is, instead of calling this the oil layer, we're going to call this the organic layer. Okay, because oil and water don't mix, but organics and water typically don't mix. So we're going to see organics, and I'll abbreviate that ORG. We're going to see organic layer floating on top of water most of the time. Now, some of the beauties of this process is that it's real quick. You get to take your reaction mixture and you put it right into the sep funnel, and you get a separation, and you can do that pretty easily. But one of the things that I want to make sure that you realize is that there are times when this can be a little bit tricky, and there are times when you have to be careful about what you're doing. Okay, so I will make sure that I point out those times where you're careful, but or where you have to be careful. Even though it's quick and it's fairly straightforward, and it's a process that you're probably familiar with for a long time, it's still something that you have to be careful with, and you don't want anything crazy happening in the lab. Okay, so what happens before extraction? The first thing that you're going to need to do is determine if your reaction mixture has two layers. This process only works if there's two layers. Okay, so here you can see very easily that this reaction mixture has an organic top layer. Well, you don't know that it's organic, but I'm telling you that it's organic. And a water bottom layer. So as long as there's those two layers, an extraction is a possibility for separation. Okay, and so once you know that there's two layers, one of the things that you probably want to do is increase the ionic character of the water layer. What does that mean? Well, when you have water, your compound, in this case your compound is cyclohexanone, that cyclohexanone a little bit is going to dissolve in the water, not because of anything other than that's just what it does. So the organic layer is going to have most of the cyclohexanone, but what we want to do is we want to increase the ionic character of the water, because when we increase the ionic character of the water, that means that we're making the water kind of, I'm going to say that we're making the water more polar. Okay, water itself is polar, and the reason why organic layers don't mix with water is because organic layers are not polar, or a lot less polar than water. Okay? So by adding something to increase the ionic character of water, what you're doing is you're making water more polar and forcing more of the organic compounds to move from the water up into the organic layer. Okay? So how do we increase the ionic character of water? Well, it's pretty straightforward. Ionic compounds like sodium chloride or potassium bromide, those ionic compounds mixed with water will force organic into the organic layer. It's just another way to make sure that you are separating things as good as possible, as well as possible. Okay, so the other thing you're going to have to do is you're going to have to rinse the reaction vessel. Okay, so this reaction vessel is going to get dumped into here. Okay, and so what you're going to want to do is, and you can see it a little bit on this picture, is you can see that there's organic junk floating on the outside of the reaction container. So by rinsing this with a solvent like ether, okay, you take a little bit of ether. That's what we're using in this lab. You take that after you have already added it to the SEP funnel, you swirl it around, and then you add that to this. All that's going to do is increase the level of the organic layer. Okay, the organic layer is going to increase in height or in volume because you've added just a little bit of solvent to it. Again, it's another way to make sure that you're getting as much of the organic compound as possible. Okay, so now that you do the extraction, this is when you have to be careful. So now all your stuff is in the all your compounds are in the SEP funnel. Now we're ready to go. One of the things that's going to end up happening is you're going to want to make sure you mix this. Okay, and how you do that is you take your SEP funnel and you turn it upside down. That's the stopcock. Let's see if I can draw an upside down SEP funnel. That's not so bad, everybody. Okay, and of course the stopper is in it. Okay, so, and then you're going to shake this thing. Okay, and when you shake it, that can cause a reaction to happen between these two layers, and it may build up pressure. Pressure, and this is a closed system, pressure in a closed system is bad. So in order to relieve that pressure, you're going to open the stopcock, and you'll actually hear a little bit of a whooshing sound. And that whoosh tells you that things are mixing and doing their thing. But that also indicates that there's pressure building up in the system. So you want to make sure that you relieve that pressure, and you don't want to just mix it and then just let it sit there, because then you run the risk of losing grip, and this comes out, and then as soon as this comes out, if it's too much pressure, then all your stuff just comes out of this, and it's bad news. Okay, it drips all over your hand, it gets all over your hand, it falls all over the floor. So you want to make sure that you vent properly. Okay, that's what you're doing. You're mixing and venting. Okay, and then you put it and you let it sit. So after you mix and vent, you want to put it back in your system or your apparatus so that you can let it separate, and then you're ready to carry on. Okay, now once you're ready, once you do that, now here's what happens. You get out a Erlenmeyer flask. You get out an Erlenmeyer flask. And then this bottom layer here is going to drain out the bottom, and you're going to put it in the first Erlenmeyer flask. You should take out the the stopper, because if you don't take out the stopper, you're not going to be able to drain. You need the air to displace the liquid that's being drained out. It'll glug. It's like a water cooler, right? So you want to make sure you take out the stopper. But you drain the bottom out and you put it in here. So now in here, you're going to have, I guess, a water layer. Okay, I'm trying to make it the same color here. So this is the water layer. Okay, and now on the top, the top layer, you get another Erlenmeyer flask. Okay, again, I'm really bad at drawing Erlenmeyer flasks. But then you pour the top layer out of that Erlenmeyer flask. And now that you have this yellow organic layer here, and it is mainly separated. Okay, so the extraction happens right here. You pour the bottom layer out the bottom and you get your water layer. Now for this particular lab, Lab 9, the water layer, you're going to just dispose of this. Okay, this has junk in it. What does it have in it? Well, it has acetic acid salts, sodium hypochlorite. It's got things that you don't want. In the organic layer, what's in the organic layer? Well, you should have cyclohexanone. Hopefully it's oxidized. And you should have, or you may have, a little bit of cyclohexanol. Okay, it depends on how well you did the reaction. Okay, so these two things are in here. Plus, you also will have ether because of your rinses and your solvent stuff. Okay, so that's pretty cool. But now what happens afterwards? Okay, well, we have to take this extraction and we have to ensure that we get all the water out of it. Okay, so how do we make sure we get all the water out of it? Well, this is where we need a drying agent. Okay, a drying agent absorbs water. Okay, and a drying agent could be something as easy as potassium carbonate or magnesium sulfate or something else. You'll see in the lab what we're using. But what you're going to do is you're going to add it directly into whichever one it is, directly into the flask. Now these two are ionic and they aren't going to dissolve in an organic layer. So they're going to develop this little layer at the bottom, and what that is going to do is it's going to absorb water out of the organic layer. Okay, again, you want to make sure that you get all the water out of the organic layer, because all of the water is kind of the bane of organic chemists' existence. Okay, so you want to get all the water out of that organic layer. Now, once you have all the once you do this, the drying agent will sit at the bottom and it'll start clumping up. It'll start congeal. It'll start turning into like rocky substances. That means that it's absorbing water and it's doing its thing. So after you dry your organic layer, now you're going to take this, and if you can imagine, your organic layer here has organic in it, but it also has a solid in it. So how do you separate a solid from a liquid? Well, you're going to filter it. So you take this, you set up a filtering apparatus, a filter paper inside a funnel, and you're going to filter this. All the solid should hang out in the filter paper, like you're making coffee, and then down here in the bottom, you will end up with all your organic liquid with no solid in it. And then it's sure to be as close to have water-free as possible. Okay. The last thing that you're going to want to do is make sure that you take a little bit of ether. Okay, and then rinse this off, and then put it in here, and take a little bit of ether and rinse this out, because sometimes some of the organic is going to get trapped in the filter paper, and you're going to want to rinse that down so that any of the solid is there. So now you could take this, and it's all liquid, and cyclohexanol and cyclohexanone are liquids. And so going back to Organic One Lab, how do you separate a mixture of two liquids? Exactly right. Okay, so this is a great way to do some crude separation to get ready to do your final separation. So that's how you do an extraction, and if you have any questions, feel free to reach out, and have a great day, everybody.